So here's that example that I said I wanted to go over with you that demonstrates an application to logarithms. So there are a lot of human responses to stimuli like sound, light, pressure that use logarithmic functions. And one that I mentioned is sound. So the intensity of a sound must be increased many-fold before we can feel the loudness that if it is being doubled. And so this psychologist formulated the law as such. S is equal to K times the log of I over I sub 0. Now that S represents your subjective intensity, how you feel about the intensity of that sound. The I is the actual physical intensity of that stimulus. And the I sub 0 is what stands for the threshold physical intensity. K is a constant that's going to depend upon which sensory stimulus we are addressing. In this one, we're addressing sound intensity. So the perception of the loudness of a sound, which is measured in decibels, is based upon the physical intensity in watts per square meters. And it's given by this logarithmic function. It's a log in base 10. So the number of decibels can be determined by taking 10 times the log of your subjective intensity divided by the actual intensity, or the physical intensity of a barely audible sound. So if we tell you that we want you to determine the decibel level or the loudness of a sound whose physical intensity is 100 times that of a barely audible sound, then that means that our I in the numerator of this logarithm is just 100 times I sub 0. So I'm going to substitute 100 times I sub 0 in for I in that logarithmic function. And I'll get the decibels is equal to 10 times the log of 100 times I sub 0 divided by I sub 0. Well, clearly those I sub 0s are going to cancel. And so now I have the number of decibels is equal to 10 times the log of 100. Well, let's just pause a minute and think. Let's ignore that 10 in front and think about what we discussed in class. The log in base 10 of 100 is equal to what number? The log in base 10 of 100 is equal to what number? To what power do we need to raise the number 10 to get it to equal 100? I hope you've come up with 2, because 10 to the 2 is 100. So 10 times the log of 100 is the same as 10 times 2. So the number of decibels where the physical intensity is 100 times the original, or that of a barely audible sound, that is equal to 20 decibels.